Good morning, everybody, and welcome to the penultimate AP Calculus BC Live session here on YouTube. Penultimate means second to last. So we only have 2 more episodes, and we were just talking this morning, Tony and I and our producer Sarah, how sad we're going to be that we don't get to do this starting Monday morning. We're going to miss you guys, and we will wish you well on your exams. But it's been a great run. And we're looking forward to finishing it strong today and tomorrow, but it'll be a sad moment when we wake up Monday morning and don't have to hop on and make a lesson. But we are today talking about some more AP exam prep. During our AP exam prep week, we're going to be debriefing the question from yesterday. We did a free response question, a sample from like what the first question might look like on this year's exam, a 25-minute timed test. We're going to go over the answers and solutions to that today. And then we're going to follow up with one more timed FRQ, a final chance on these lessons for you to practice, not just uploading your answers, but really getting used to that mindset of timing, seeing a problem on the computer, because that's really a weird way to take a test, right? I mean, we don't do that normally in school. And so don't underestimate the practice and the importance of practicing, seeing a question on your screen, writing your answers on paper, and then uploading it, because it is just different enough that if you don't practice and try it a few times, it might take you out of your calculus game. So make sure you join us today and work out that problem and go along with us with the timer. So we'll finish with that. As always, you can find the resources for today and the link underneath our video. So make sure you grab those. I uploaded the problem for today in there. We waited to the very last minute. That way nobody would have it too soon. So if you want to, you can download that, pause the video, get that question if you want to print it out or have it on your screen when we go to do our timed problem today. But if you don't do that, don't worry. We're going to have the whole question on the screen, so you'll be able to follow along just from there. And as always, I am joined with my great friend, Tony Record from Avon High School. Tony, how sad are you that we're not going to get to hear the intro music every morning starting Monday?
I'm very sad. I'm very sad. I'm very sad. Oh, we're on.
I think I'm mostly sad that I'm not going to get to hear your dad jokes every day. These the Tony Record. Actually, we might not even call them dad jokes. We might just start calling them the Tony Record jokes. So from now on, students, when you guys come back into school next year, you come back into class and your math teacher tells one of those math teacher jokes, just be like, ah, man, that's another record joke. Don't even refer to them as dad jokes anymore. Tony, I know we got a lot to do today. We got a lot that we want to share, right? A lot of things that we want to get to today. And you've been mentioning all week that it is Teacher Appreciation Week, and hopefully our students are recognizing their teachers, right? Their math teachers and other teachers, and thanking them for what they've done. And we're gonna, I know at the end, have some more tweets to do that, but I wanted to briefly recognize Tony for a moment. And I'll tell you something. Tony is an actor. We all know that, and he's very good at like playing on camera and playing the role. But I can say sincerely, he has no idea. He has no clue that we're doing this. So any reaction that Tony has is going to be completely authentic and genuine. Tony really is a good friend of mine, and when I start talking about him now, I'm almost getting emotional because he's incredibly humble, does a lot for students, never wants to take any credit, never wants to be on the spotlight, always gives credit to others, builds up other people, but because of that is one of the reasons why he's an amazing teacher. So I thought I would come up with today to share with you at home a little bit more about Tony. So these are our top 5 Tony Record facts of the day. So here's our top 5 Tony Record facts for you at home. Number 5, you've seen Tony's handwriting on the screen, but did you know that Tony's handwriting is so perfect that Microsoft Word actually has modeled 3 different fonts after him? So they've modeled 3 of their fonts based off of his handwriting alone. They asked him to do the entire category, but he just thought that wasn't right. So 3 fonts named after him. Tony Record fact number 4, you've seen him sing, you've seen him perform the guitar on these videos, but did you know that the Queen lead singer, one of the greatest performers of all time, Freddie Mercury, was actually inspired to enter the music industry hearing Tony perform and wanting to be just like him? Tony Record fact number 3, he's a calculus teacher, we all know that, but did you know that Tony grew Avon High School's AP Calculus program from 12, his first year they had 12 students, and now they're verging on 300. And this is not a school of 10,000 kids. This is a school that has just brought in so many students willing to try to bring them along to nearly 300 students. And I know Tony would give a lot of credit to his good friend and a friend of mine who has passed away recently, Mike Hamlin, who was also an early AP calculus teacher in the beginning days, but in the last many years, Tony has just blown up that program due to his amazing teaching, but also his willingness to include students, help them no matter where they are, and encourage them to challenge themselves and give them a soft landing. Fact number 2. Did you know the Guinness Book of World Records, they don't call it you're wondering why it's called a world record, where that comes from? It's actually named after Tony. The Guinness Book of World Records is named after Tony. In fact, if you look at the record book, those are actually all the second best records in the world, because Tony actually has all official world records, but because of his humility, he doesn't really want to publicize any of that. So he just lets them be second best and call them the best. And the number 1 top 5 Tony record fact that you may not know this, but there's a World's Greatest Calculus Teacher Award that's given out, and Tony's won it 20 years in a row by the World Teacher Association. It's a group. It's probably real, but he's declined it every single year in order to allow other teachers to be honored because of his humility and wanting to recognize and appreciate other teachers around the world. So that is our top 5 Tony record facts of the day. And Tony, in all seriousness, you are an incredible teacher. Obviously, you're an incredible friend. You've been putting on these videos for 30 some days, and we've been collaborating night and mornings. And you put up with all my crazy ideas and my late night changes. And you've done all of that because you just want to provide the best support, not just for your own students at Avon High School, but for any student who happens to come across these videos. So I appreciate you today, and I appreciate all the things that you're doing to help me become a better teacher, to help my students become better students, and to help all the students around the country. So those are our top 5 facts of the day. And we're going to jump in.
I'm speechless. And then this was a shock. This was a surprise. So now I have to get you tomorrow. So
no,
I have
you
to
don't.
start thinking
this
of some
is
things.
why I waited till today, because I know that now we already got tomorrow's show kind of all lined up and timed out. And so if Tony knew I was going to do this, he would have never let me do it, because that truly is his humility. He doesn't want any spotlight. He wants to just shine the light on other people. But let's recognize Tony today. So if you're on Twitter, you've been following us on Twitter, give Tony a tweet today. Tweet him out. Tell him what you've loved about these last 33 days. Thank him for the lessons, and then maybe share. You only have 140 characters, right? Maybe share one thing that you've appreciated the most. Either one lesson he did, one illustration, one joke, one thing he helped you understand better. What did you enjoy? Let's just flood Tony with some love today on Twitter, because he needs that. I'm sure, like all of us, he's exhausted from doing all of this balancing out. So that'll help him finish strong tomorrow, before I pie him straight in the face. So he is getting pied in the face tomorrow. So no matter how much I love you, Tony, you're not getting out of that, just so you know. So it's coming today or tomorrow. So just be ready for it. So with that said, what if we jump into what we got on tap for today?
All right. Well, let's take care of a few things here by way of some housekeeping, and start with that t-shirt thing that we've been talking about. I know it's kind of been on many of your minds, but in case you've not seen, here is our design, and we are going to be shipping out several of these shirts to some very lucky winners, both students and teachers. And the way that you would enter the contest, as always, is make sure that you've tweeted out one screenshot of your AP exam portal confirmation page. You only have to do it once, and we'll assign everybody a number, and we've been picking some random numbers to choose our particular winner. Make sure that you have @PassWaterB or @APCalcTeacher in that particular tweet, and hey, we'll just make it happen. We'll make it happen. We've had several winners already so far. What you have to do is basically stand by, and I'll send you a direct message through Twitter if you're able to receive them. If you're not able to receive them, I'll just probably reply to your tweet. And then we have to coordinate with your teacher, because we need to communicate with them, because we need to ship it to them or to their school and not you, just for security reasons. And we'll make sure that you get that shirt. And I'm pretty excited about that. Hey, the week, like I said, it's closing down. I am kind of sad too. Today's topic really is we're going to debrief our question that we went over yesterday. And I know it's kind of confusing. That was question 1 because that's the longer question. And so we'll take care of that here in just a few moments. And then you guys are going to have just one more practice question. In fact, I think, Brian, this might be one of the last calculus problems that we share
Mhm.
with you. It's just another brilliantly written problem by Brian, and you're going to go ahead and be able to practice that. It's the shorter one. It's the 15-minute question. Don't think we're going to have the submission portion attached to that problem because we think that you've probably practiced that enough. And then we will probably debrief that tomorrow. It says we have the debrief here in today's schedule, but look for that to probably begin our show tomorrow. And then tomorrow's show, well, there you go. Last minute tips. I YouTube live recap, tearful goodbyes. I think Brian's got a few surprises on hand. I don't even know what they are. Like this pie thing, I don't think it's going to happen. But hey, it's going to be a great end to a wonderful 6-week run with you guys. Again, today's show, I'm going to have a few important reminders here before we dive into our debrief of FRQ1, and then we move into our practice question very shortly after that. And like I said, the debrief will likely happen tomorrow of that FRQ2. Haven't already? Right? We can still say do this today, but definitely practice your uploading solutions procedure. Make sure that you have decided exactly what form that you want to do that, and check out the AP checklist from the College Board website. And if you haven't watched this very wonderful, informative short video, you definitely want to take care of that as well. And then Brian went into really great detail with this slide. He put this together yesterday. It's excellent. I loved it so much. I'm like, oh my gosh, I have to use that with my own students. It was very clear about separating the text attachment to the photo attachment. So definitely look at this slide. If you didn't get a chance to look at it, you can take a screenshot or a photograph of it, but this really kind of delineates the two different submission processes. And we encourage you, watch yesterday's video if you haven't already, and then you can even go back to Tuesday and you can watch the whole upload process that we explained in great detail at that point. So, all right. I think we're debriefing. Is that right, Brian?
Let's do it. So this is the question from yesterday. I hope you had a chance to do the problem. I hope you had a chance to practice uploading it. And we're going to go through the solutions today. And on a lot of these problems, just so you know, we're not going to spend a ton of time on the solutions. I just want to point out a couple of things on each part, so that way you know sort of where the points might lie and what you have to show and not show. Sometimes in our typed up solutions, we have more details than you might have to show on the exam. So students always wonder, how much do I have to show? How much do I have to explain? So I would just make one quick comment. Make sure that your exam tells a story, right? When you're writing your solutions, it should be telling a story about what you're thinking in your head, right? So if you're skipping steps, we can't see that. We can only score, we can only give points for what's actually on the paper. So if it's not on the paper, it hasn't told the story. So don't leave important details out and just assume that we know what you were doing. When you write out work, side work, that's not really for you. It's not like your own benefit so you can get an answer. All your work is for us because we're giving points along the way as you show us processes and ideas that you're executing properly. And without those steps, then we're not going to be able to give you those points. And in fact, we call that bald answers a lot. And our guest host, Steve Kokoska, mentioned that on his common tips and errors the other day on Tuesday, about how a bald answer is when students have an answer with no real supporting work. And a lot of times that will give you no points at all. Without any work, you might not even get the answer point right, but the answers are always less than half of the total points on a problem, right? On the exam. So having all the answers right but no work, uh, the answers are like 1 point for each part, right? Whereas the entire work is always going to be worth more than just the answer. So the work's really important. So always keep that in mind. So part A was the average rate of change. That's a topic we learned about way back when, right? AROC, average rate of change, is just the slope. There's a difference between average rate and instantaneous rate. So we had to find the slope of the graph of G from -2 to 5. And so we have that nice setup right there. A lot of times in the exam, just showing that setup might even be worth a point because that's what we call like entering the problem, connecting it to calculus, that you knew that we would have to set that formula up, and showing that setup would maybe earn you that first point. Plus, it gives you a better idea of what to do next. And then what's cool about this problem is it took that really early idea of slope, right, from way back in unit 2, almost the very beginning of unit 2 in the early in the year. But then to find that average rate of change, we had to find G of 5 and we had to find G of -2, and that involved an integral. We had to find the area, the geometric area under that curve, right? So it really connects integration with something way back early in the year. And the exam is really good about doing stuff like that. So we had to then figure out how to find those two values. And that's what you see on the screen. So I'm not going to go into big detail on how those numbers came from. Take some time to do that. And your answer might look different than what we see here with the numbers because you might have simplified it differently. But that's what we have the final answer there on the bottom line. That's what the equivalent answer should look like. So you know if your answer matches that, then you are on the right track. The only thing I might point out is on that second line, the first part of that takes like half of the second line. We could have stopped right there, right? As soon as you have numbers plugged in, that big long expression, we can stop. There's no need to simplify and reduce that any further. And I would strongly recommend on the exam this year, especially once you have those numbers plugged in, stop, right? Resist the urge to keep going because time might be a factor. And then little mistakes of typing things in wrong on your calculator or making a mental error would only hurt you in the long run. So stop once you have all the numbers plugged in. Part B of this problem took us to a limit question. And as soon as you see a limit question, it doesn't have to be L'Hopital's rule. Last year on last year's exam, they actually had a limit that wasn't L'Hopital's rule. But when you see a limit problem, really the first thing that you should do instinctively, no matter what, is just take the limit of the numerator and take the limit of the denominator as two separate ideas. That's what you see on that top line. Those are the conditions for applying L'Hopital's rule. And so we took the limit of the numerator and we had a graph of s so we could find those values. For the denominator's limit, don't forget we have f prime involved, right? And which is, since we have a graph of f prime would be the slope or the derivative of that graph. So we have to look at the graph and interpret how do you find f prime from a graph of f? We got to think about the slope of that part of the graph. And so we were able to take both those limits. They were both 0, so we knew it was indeterminate form, which allowed us to apply L'Hopital's rule. And so on that third line, you see the L'Hopital's rule being applied there. L'Hopital's rule, take the derivative of the top, take the derivative of the bottom separately, and then reapply the limit. Make sure that you're always showing proper limit notation. That's going to be pretty important, right? Proper limit notation. I probably will say we have a slight error, I think, on this key. I wonder if you caught that, because in that third line, the beginning of that third line, it has the original limit, which is perfect, and then that equal sign. We need a limit right there as well, don't we? When you apply L'Hopital's rule, when you take those derivatives, the limit is still there. That should have said limit as x equals -1. So we'll make sure we update that key for the Dropbox. That way you'll have it correct. I don't want to have you something incorrect, but make sure you have a limit still, because that limit is always there, right? Every time you're doing a limit problem, the limit is always in front until the moment you actually plug in values. Once you start plugging a number in on that third step right there, that's when the limit would go away. Okay, so we got to be really careful about that. So we would actually possibly not earn full points on our own solution. And I'm sure Tony and I would tell you, we did that on purpose just to make sure that you would see how important the notation would be. Right? This is why people don't get perfect scores on the exam, except for you guys this year. Maybe you all will. Right? So that would be part B. Part C of this problem is asking for a point of inflection. Right? We have some of those ways we can find points of inflection. We have to take the second derivative of g, and so we have to do the second fundamental theorem of calculus, right? We have g defined as an integral, so we have to find g double prime. And in the Dropbox, if you haven't noticed it, you'll see a couple of files in there where I put some justifications on there, and one of them is how to work with like points of inflection and things like that. So might be a good reference sheet to keep handy for the exam. But in this case, our two answers were 0 and 2. And then the communication is going to be pretty important here. When you explain your reasoning, how do you explain your reasoning? Well, one possible way is because g prime, which equals f, we made the connection there, changes from increasing to decreasing or vice versa, right? You also could have said there, if you wanted to, g double prime, which equals f prime, changes sign. So you could have mentioned that g prime, which equals f, changes from increasing to decreasing or vice versa. We see a change in direction of f on the graph, which would be one way to explain it. Or we could have used g double prime equals f prime changes sign. You gotta be careful you don't mix those two reasons up, okay? And then finally, part D of this problem, for the first half of the stem, is evaluating an integral. And hopefully, as soon as you see those parentheses, the bells start going off like, oh, this is probably going to be a U substitution problem. When we integrate something that has parentheses that's not just an X inside the parentheses. It's almost always going to be U substitution. So we just set whatever's inside of those parentheses equal to U in this case, even though the problem looks different than probably how you practiced and learned U substitution, right? When you learned U sub originally, I'm sure you were doing problems like sine of 2x minus 3 or natural log of some stuff in parentheses, or just more like equations, not so much with f primes and f's and f double primes. But this is how the exam is going to give you a chance to practice those skills and test those skills, but also ensure that you're not just going to be able to type something online or use an app or a computer or a calculator to solve it for you. So we get a little bit of U sub involved there. It works the same way. We can still integrate f prime after we do U sub, and we get f, and then we're going to end up getting our final answer there of 1 if you simplify it, or that second to last line would have been perfect that we're underlining right there. We got to make sure you don't stop where it says f of -2 minus f of 2. That is not acceptable to stop because that's not a numerical value. You have to get it to a point that if somebody had a regular calculator and just your answer, they could type your answer in on a calculator. So they wouldn't know how to type in f of -2. They have to go figure it out for themselves, but that second to last line would have been fine. So that's going to be A through D, right? A lot of points there. You might have noticed if you took this problem, it was a lot, and maybe you didn't get it finished on time, and that's okay. Don't panic on that, right? But don't get bogged down on one part. That part A was just, oh my gosh, I got stuck on that problem for 5 minutes. Move on. Find some parts that you know. Find what you feel most comfortable with. Get all those points first, right? All the ones that you feel good about. You don't have to do the problems in order. Just make sure your papers are well labeled, that everything is clear what part you're on. Maybe leave some spaces on the paper if you want. But do what you feel most comfortable with. And then you can go back and backfill the ones that you're not sure about. And then don't panic if you don't get them all done, because we know you can still go to 5 if you leave a part blank. And then Tony is going to walk us through the second half of this problem, which included a new graph and a new stem.
Yep. The last three parts were just very cleverly crafted in the way that they infused a lot of topics from, say, the AB portion of your course with a couple of BC options in E and G. So obviously, part E, you're asked to write a third-degree Taylor polynomial, something that we've practiced with you many times. But boy, it's sometimes so interesting the way that those coefficients can begin to be developed. And you'll notice that here's the traditional frame that we've always laid out to write a third-degree Taylor polynomial. It says Taylor, but although we're centered at 0, we sometimes refer to those as Maclaurin, but a series centered at 0 can still be called Taylor. It encompasses all places that we can center. And our h of 0, we have to think about, well, how we go about finding that. Well, the stem had mentioned that this graph here is a graph of h, or a partial graph of h, and we can just read right from the graph the 3. I love this h prime. I love little connections like this because a student might temporarily look through the stem to see if there's any information about h prime, not realizing that, well, that's really manifested by this tangent line. And that tangent line being drawn to the curve at 0 allows us to utilize it for this particular problem. We have to focus on what is the slope of that line. Really a central idea. It's probably the first really big idea in calculus, knowing that the tangent line slope is the derivative. And so that's how we get that -2. And then the h double prime and h triple prime, those enter by way of the table. And so a student has to understand notation, of course, and understand that this table is only good for when the n is 2 up to 4. And then you can see how those two values, the 3 and the -23/2, play a part. And boy, those factorial pieces, the 2 factorial here and the 3 factorial there, play a very vital role in making sure that you assemble, put your furniture together correctly, and then have a complete answer. This answer here would be perfectly acceptable. However, the simplified version would look like that. Part F returns a little bit to our AB roots, maybe sort of right at the end of the AB curriculum. We talk about these volumes. This particular topic won't be tested on this year's AB exam. However, it is fair game for your particular exam. And we had to use the washer method for this problem. And the reason is because our axis of revolution would be somewhere right about where my cursor here is moving, just below the picture. And you can see that there's a lot of empty space between that shaded region R and that axis of revolution. The general form of a washer method is some kind of a radius squared minus another radius squared. We make sure we have the pi out in front. We have our dx that acts as our thickness or our height of these cylindrical washers, these cylinders with holes in them, so to speak. And then as far as figuring out these radius values, we rely on the very important mantra, top minus bottom, h of x minus the -2. And you can see that the solution had simplified the double negative there. And then for the portion here, we have the curve. That would be the nearer side of that boundary to our axis of revolution. That's a tangent line, I should say, subtract -2, and then we end up with that result for our other piece of our washer setup. And it did just say to set up. We didn't have to integrate this, and that would be problematic a little bit because of the fact that we don't know h of x. So you could see setups. We don't know, but you could certainly be looking at a setup of a volume problem on this year's exam. Part G, return back to our BC, and we can see immediately that we have an improper integral on our hands because of the upper boundary being infinity. X to the p plus 1 is our denominator. We have to have this little statement here because this problem will sort of fall apart if we don't know that p would be positive in this case. So the key here is to be able to effectively communicate what this improper integral means, right? The fundamental theorem of calculus struggles a little bit if you have a boundary of infinity. It doesn't seem to fit into the context of that particular theorem. So we can outsmart that by using our good friend the limit statement and some arbitrary constant up in that bound. And then that p plus 1, certainly want to change that to a -1 exponent so that we can manipulate that correctly and do our integration so that we can follow through with our limit. And I think we end up having to use the fact that if you have a 1 over constant b to a power, and that power becomes really big, that's going to zero out on us. And so the ultimate answer here would be 1 over p. Of course, you could leave the answer like this, unsimplified, once the limit has been taken. But 1 over p is the most simplified version of that answer. And I think Brian's going to get you all set up for your last problem.
I know we got a lot of last coming up today and tomorrow. It's the last this, the last that, right? Hopefully this is not the last practice that you do before the exam. This is just the last practice that we're going to do online with our lessons before the exam. But you've got many days, or I say many, 4, I guess, right? Friday, Saturday, Sunday, Monday, to practice a little bit each day. So this is our last timed FRQ on here, and we will definitely go over the rubric for this one tomorrow at the beginning of our show, kind of like we did for the question from yesterday. So if you don't have it, you can pause the video now if you want to download the problem from the Dropbox, but we're going to put it on the screen so you'll be able to see it completely on the screen. But if you're working and your screen's small or it's kind of hard to see, then feel free to pause and download and print off the question from the Dropbox. So it's going to be a 15-minute timed practice. We're going to put the problem on the board, and then we're not going to do the whole upload process right now, but we'll stop you when the 15 minutes is up, and we would strongly encourage you to practice that upload process. Don't just do it once. Sometimes my students will do something incorrectly a few times, and then once they do it right once, like, okay, now I got it to work, I'm good, right? That's not a really great way to go about things because that's just one time. You want to practice it multiple times until you no longer ever make a mistake. You want to practice it until you do it right 3, 4, 5 times in a row. That way, you know, when the exam time comes, you've got this down pat. You know exactly how long it takes to upload things. You're not going to panic if something goes wrong. You can pause, kind of collect yourself and troubleshoot, right? So make sure you practice this multiple times in different ways to make sure everything's going to work out the way it's supposed to work out, right? So here's the question we're going to see today. It's a timed FRQ problem. You've got 5 parts to it. I'll let you read the STEM. It says the graph above, but we had to kind of move it to the side there in order to let you to see it. And you'll notice, look, we moved the clock today. We put it down below. Yesterday, we didn't realize that our camera was going to be over the top of that. And I blame our producer at College Board because she told us every single day, don't put anything on the top right-hand corner because your cameras will cover it. And she warned us about this when we started these lessons every single day. But I'm pretty sure yesterday she didn't tell me that. So she should have known I would have messed it up if she didn't tell me 100 times instead of 99 times. So I don't want to take that responsibility, even though it was my fault. But take this problem. The clock says 20 minutes, but remember, you have 15 minutes to do the problem. clock will turn red at 5 minutes and we'll come back on to let you know that your time is up. So take some of the advice we shared earlier. Find some parts that you feel good about first and jump into those. Good luck. All right. Well, welcome back. The timer has now hit the red. That would be 5 minutes. So hopefully think about how many problems you got through, right? If you got through four of these and you're maybe starting a fifth one or didn't quite get to the fifth one, okay, right? Not too bad. If you got through two of these, then we're going to definitely have to think more about our pacing and finding some better ways to find points. I did a session last night on another site, a little review session with a friend of mine named Mark Howell. And one of the things he said last night, which I really enjoyed, was he said, um, if what you're doing is not working, try something else, right? Of course, it's easier said than done, but if you're looking at a problem and you're not getting any points or you're stuck on it, move on, right? Go to another part that you can maybe find some points on. So don't get stuck in this. I have to do A first and then B. Sometimes there's connections between the problems. Sometimes you'll do part A and that answer might be used in part B. But more times than not, they're independent, meaning you could do part B without even looking at part A, right? And so this problem is a good example of that. And this year's test might be a good example of that because they are trying to test so many different topics with only two free response questions. And so there could be, a lot of opportunities to get points on different parts of the problem. So don't get too stuck on that, but keep practicing your timing and then keep practicing your upload speed at 5 minutes, maybe wrap up what you're doing, but make sure you keep an eye on the clock, right? I'm telling my own students, put an alarm on your phone, a couple of alarms during the test. That way you can kind of pace yourself. You don't want to look up and realize there's only 1 minute left on the clock because you are so engrossed in the problem, right? You're not going to have that proctor like you would normally have on an AP exam telling you you've got 10 minutes left, you've got 2 minutes left. Like you have to be aware of that. And so we've got to get those problems uploaded on time. All right. So with that said, take a moment today, if you haven't done it already, right? Take a moment today and after we're done with this video and just try to upload your work to the site. And sometimes I think students overlook that part. I've got this covered, right? But please trust us. Just humor Tony and I and do that. That way we feel confident that you won't have any technical issues on exam day. Just go on there, upload it, tweet at us that you've done it, right? Even if you've done it before, tweet us again. Show us that you did it again, right? Because we love to see that you're doing this until you feel really good about it. So that's it. That's the second practice problem. We'll start that problem tomorrow, a quick debrief of it. And then the solutions from yesterday's problem, by the way, we'll put those in the Dropbox later today. So you'll have a handwritten solution. And our friend Ted Gott already texted us. This is how good Ted is. He's already fixed the solution and re-uploaded it for us. So that way we already have the corrected key that we'll put in the Dropbox for you. But we always wait to put the solutions in there until after we go over them because the solutions by themselves are helpful, but you really need to hear from us what you need to show, right? What steps you need to show and how we do things on the scoring end. That way you don't think you have to have exactly what we wrote, right? We're giving you detailed solutions, but there's some different ways you can tackle some problems. So we'll make sure we highlight the important parts of those. I know you've been waiting for this because Tony, we've gotten more tweets about this than I've ever gotten in my entire life about this. And so everyone wants to win a t-shirt. And I am so impressed, Tony, because you've been talking all week about Teacher Appreciation Week. And our students, over half the tweets, a lot of students want a free t-shirt. But how many of them say, I want to win this for my teacher? I want my teacher to win this. So we've been so humbled and impressed of how many of you are wanting a free shirt, but really you're also wanting to honor and give a prize for your teacher. So Tony, I think you're going to share the winner today.
Yes, I am. We picked a random winner, and that person is Meg HANA loves calc. Your Twitter name is @editsgene. So if you're watching, anticipate a direct message from me, and I'll give you some information about how you can acquire the shirt along with your teacher. So congratulations, Meg.
Perfect. And Tony, were there any winners from yesterday that you haven't been able to get a hold of yet that you might want to remind in case they're watching the video today, or has everybody been able to respond to your messages?
I was able to get a response from one of the winner's teachers.
Okay.
However, that teacher, I need to reach out to make sure I know which winner it is. But yeah, make sure if you were mentioned yesterday, that would be Kevin, Jenny, and Athletic Wear, that you have reached out to your teacher so that they can get into contact with me so that we can get the ball rolling on this.
Yeah, and we want you to have the shirts, but we also want to make sure that we have a way to give away all of them. So Tony, I'm thinking if we don't hear from the winners by tomorrow's show, we might have to draw an extra person to take the place of that person because we want to make sure that somebody wins these shirts, right? So if you tweeted at us, you had to have been watching the show. So look for Tony's messages and look for his a couple of you, he even tweeted at you because he wasn't able to message you, but make sure you respond because if not, we're gonna have to give it to somebody else. Is that right?
That is right. That is correct.
Awesome. One of my favorite parts of every show is the tweets with Tony.
Our Teacher Appreciation Week edition of Tweets with Tony. And I wonder if my first one, if I've developed the slide correctly. I don't even know if the rectangle disappears on this one, does it? I think we may have to slide it out of the way. It's like, hey, at least I got the timer to work, but okay, maybe it did work. Okay. So our first teacher, it's a huge shout out to Mrs. Rounkles. Hopefully I pronounced that correctly, but she's such an amazing AP Calc teacher. She's had our class up at 7 a.m. watching the YouTube live stream. So you must be on mountain time out there, I guess. Even though it's early, I'm so grateful to her because I have learned so much and I feel so prepared. Congratulations. We also want to give a shout out to Mr. Ambrose, my BC teacher. He has always simplified many concepts that seem confusing at first. Also, when we learned volume, he brought in food items with cross sections that matched those of the solid we were discussing. I don't know about you, Brian. That's a class I want to go to. That sounds fantastic. And for our third tweet, shout out to the calc teacher, Mrs. Kramer. She does a phenomenal job teaching the course content and has really taught me how to look at math from a different perspective these past 2 years. Flanagan loves you. So there you go, our 3 featured tweets of the day in honor of Teacher Appreciation Week.
Wonderful. And I want to just acknowledge 2 more quick teachers. One of them is a friend of mine, a teacher that lives nearby. His name is Peter Beck. He teaches calculus where my kids go to school. And I just saw on Twitter and on Facebook, he was named the Teacher of the Year for their high school, for their corporation, a finalist for their corporation's Teacher of the Year. So a great calculus teacher and friend. I want to make sure that we acknowledge him and appreciate the work that he's doing. And so many of you teachers who are watching this do so much for your kids. And a lot of you probably have been acknowledged for that as Teacher of the Year or a candidate. And so those are all well deserved. And then finally, on a little bit of a sad note, but I've had a couple students, Tony, message me and tweet at me. One of their teachers, Mr. Michael Frisbee, passed away just recently, kind of unexpectedly, and he's taught calculus for many, many, many years. And the students just were wanting to give him some honor, to thank him for the immense contributions that he's given to their class and to their lives. And so we want to thank Mr. Michael, Frisbee, and we want to let you know our hearts and our thoughts and prayers are with all of you who are around him, his students, his family, his friends. But based off of the tweets and the messages I've received from students, clearly he was an amazing teacher, an amazing man, an amazing father, friend, coworker. So we want to thank him for his efforts he's put into all the students. So definitely want to acknowledge him, acknowledge all of our teacher friends who are doing so much every single day. Finally, today we have our pets of the day. On the bottom right hand corner, I hope this picture is big enough because it cracked me up. These are some chickens here eating, and if you can notice in the corner, the student here has their laptop open with our video. He's making the little chickadees watch some calculus while they eat. So it's kind of a good idea. I'm thinking now, mentioning your tweet, Tony, about the teacher bringing some food in during volumes, that's really the trick, right? Like put some food in front of people and then just stand in front of them and teach calculus, because now they have no choice but to watch you. So they don't all have names, but the one on the left here is either named Snow Boots or Lightning. He doesn't know which one, so maybe they're going to decide which one it is to figure out what the final name is going to be. Yesterday, these animals on the left here, you might recognize them. These are pets of the day yesterday, but we didn't have names for them. So I did get a follow-up text. In order, here we have Trip, Toby, and Daisy, the rabbit. So I want to make sure I give them some names because pets deserve names, right? They deserve to be acknowledged that. And then today's pets of the day we got a football loving dog and a skateboard riding Ninja Turtle here. And again, no names were given. So maybe if I get a second tweet with some names, I can give you almost like a little bit of secondary love tomorrow to follow up with the name. So that's it for us today. Tony, tomorrow's our very, very last show. Can you believe it?
Yes, it is. Yes, it is.
I am excited and sad all in once. But don't forget, my friends, tweet today, right? Your uploading process, and then tweet at me and Tony. I want to know what you've loved about Tony these last 6.5 weeks. And I want him to know so he can keep that. So every time his students roll their eyes at one of his Tony record jokes, he can say, no, look, I really am cool. I've got thousands of people that have proven it to me, right? So make sure you do that. Anything we should mention, Tony, that I forgot about tomorrow's show?
Make sure you guys tune in tomorrow. It's going to be a wonderful wrap up. We've been at this for such a long time. It was like the last week of March when we started this. So it's just going to be a wonderful culmination of all the time that we've spent together, and you won't want to miss it. And it'll be a great one to attend live, but if you can't watch it live, definitely watch it recorded. But we certainly hope that you can be here and share that time with us.
It's a can't miss. As always, our friend Anthony is going to take us out.
Stay safe, everyone. Keep learning.
AP Calc, yes, AP Calc. Welcome here to AP Calc, yes, AP Calc.